The primal problem. We want to maximize our total skill sum. Subject to 3 strict rules. Exactly A programmers. Exactly B artists. And each applicant takes at most 1 role. The first 2 constraints are global. They force the choices of applicant I to depend on applicant J. To break this dependency, we introduce Lagrange multipliers, lambda and mu, and move those global constraints directly into the objective function. We define the Lagrangian L. Let's rearrange the terms to isolate the decision variables x_i and y_i for each individual applicant. Because x_i and y_i isolated in the summation, the global problem has been shattered into n independent, trivial subproblems for any fixed penalties lambda and mu. We simply look at each applicant I and evaluate their shifted skills. Since we can only choose one state per applicant, the optimal strategy is determined by these strict inequalities. Rule 1. We set x_i to 1 if the shifted programming skill is positive and strictly greater than the shifted artist skill. Rule 2. We choose artist if the shifted artist skill is positive and strictly greater than programming. Rule 3. Reject. We do not hire them if both shifted skills are worthless, below 0. If we rewrite the condition for Rule 1, P_i minus lambda is greater than A_i minus mu. This implies P_i minus A_i is greater than lambda minus mu. This confirms that the entire decision hinges purely on the sorted difference P_i minus A_i. Compared to the combined penalty constant C, the sweep line algorithm is effectively just a fast way to evaluate these inequalities for all possible optimal values of C simultaneously. Let's break down the original problem description with 4 applicants, 2 programmers, and 1 artist using the Lagrangian equations. Here are our 4 applicants and their respective skills. If we calculate the shift P minus A and sort them descending by this difference, geometrically, we are preparing to sweep our decision boundary across these points. Because we need exactly 2 programmers and 1 artist, the sweep line algorithm tells us to split the array at index k equals 2. The Lagrangian relaxation states that there exists some penalty for using a programmer slot, lambda, and some penalty for using an artist slot, mu, that will shatter the global constraints. Let's test the perfect penalties lambda equals 3 and mu equals 5.5. Now, forget the global rules that we need 2 programmers and 1 artist. We will just apply our penalties independently. For applicant 4, shifted programmer skill is 1. And artist is negative 3.5. 1 is strictly greater than 0. And greater than negative 3.5. Independently, a programmer. For applicant 2, 6 is positive and greater than 2.5. They are also independently a programmer. Applicant 1 has a shifted artist skill of 1.5, which is strictly greater than 0, forcing them to be an artist. For applicant 3, calculating both shifted values gives negative numbers. The math independently classifies them as rejected. By simply applying the penalties lambda equals 3 and mu equals 5.5, the mathematics perfectly grouped the applicants into exactly 2 programmers, 1 artist, and 1 rejection without us ever having to write a global constraint or a priority queue. Furthermore, our separating line constant C equals negative 2.5. If we check our sorting difference P minus A against this line, app 4 and 2 are greater. App 1 and 3 are lesser. The sweep line sorting method works because it implicitly finds this exact C boundary, while the priority queues handle the exact lambda and mu rejections natively by discarding A weakest elements. To prove this visually, let's plot our 4 applicants on a 2D grid of programming versus art skills once again. Our Lagrangian math dictated that the boundary is the line A equals P minus C. When we run standard array sorting by P minus a descending, the computer is actually dropping this exact decision line down the grid. To fulfill explicitly 2 programmers and 1 artist, the sweeping line naturally halts exactly at a mathematically proven threshold, C equals -2.5. And just as the Lagrangian numbers proved, app4 and app2 are securely swept into the programmer region, completely separating them from the artists above the line.